Hello, it's me, and I'm going to attempt to answer some more very good viewer questions. But there's going to be a theme to the next two, and that has to do with this thing that I'm going to call apparent corner parity. It's a situation where corners of various puzzles seem to be mixed up, where you have to do a swap of two corners, and that's all you need to do. Everything else is fine. So here's the first question. This comes from Taylor Freeman, and this is regarding the hexagonal prism puzzle. And his question is, you can see that two corners are in the right place, and one of them is even turned correctly. That would be this. So as you recall with this puzzle here, this is a side over here, and these are the two corners that are in the right place. You can see the colors here are fine. This one is rotated in the right place, but the other two need to be switched. This needs to go here, and this needs to go here. I've taken the puzzle apart several times, but I have always reassembled it in the solved position. Let me know what you think. So what I did is I tried to get this in exactly the conformation that he had. Now bear in mind, substitute the blue for the yellow. So mine is a slightly different color for some strange reason. But anyway, here's the first picture over here. You can see this up like that, I suppose. We've got the white over here. Again, this should be yellow and this should be blue, but otherwise it's in the same configuration here. Then just to show more of that, he's got it in this configuration over here as well. So you see the orange, green, and silver. You got this over here. Again, substitute this for yellow, but you can see that this is in the same kind of position. What I like about viewer questions is trying to get it in exactly that conformation. So here's the other one again. Pretend this is yellow. This is the same over here. This is what he's got. And just for added effect, there's this over here as well. So basically what he's showing is that this is the last layer. These two are in the right place. This is even rotated in the correct place. All these are rotated right, but these have to be swapped. So the question is, how did this happen and how do I unswap it? Well, the fun thing about these mods is that by changing the shape or changing the color or making them one color, it's easy to get false equivocation. So right away, by false equivocation, translational equivocation means that you can substitute one piece for another piece. So looking over here, these three can be interchanged with each other. So too, these can be interchanged with each other. These cannot be interchanged, but they have rotational equivalency. And this little corner here has rotational equivalency as well, which means you can rotate this, it'll look exactly the same. Rotate these guys, it'll look the same. Translate these guys, it'll look the same as well. So it ended up in this configuration. Well, the best way to talk about getting through this, and I'm going to get as far as we can, my first question is, did he end up popping any of these out and rotating the centers? And that did happen, but apparently didn't happen all the time. But this represents this configuration over here, just by way of demonstration. So anytime you see what appears to be a corner parity, understand that what you're seeing is not really a corner parity. There's no such thing as corner parity. As a matter of fact, in a 3x3, as a matter of fact, in this kind of a puzzle, a 3x3, there's no such thing as a parity really, because you're not changing the parity of the puzzle at all. So what appears to be a corner parity is actually a parity of edges. So when you get a situation like this, no matter what the puzzle, look to see what is happening with your edges, because that's where the key to this problem is. So we're going to use this. Now, the reason why I say it's this situation is you can't have a single swap of a corner. The only way that that's going to happen is if you can swap these two and swap edges. Well, it turns out we can swap these edges just fine, but you can't swap these without flipping these. So this is this kind of a situation. So when you see this in this puzzle, this hexagonal prism, it actually looks like this. You can see these corners are in. If I really wanted to recreate this situation, I would have this rotated out a little bit. So why don't we do that? Okay, and then we can maybe bring this here. Okay, so this is just so that it looks a little bit more like that, where you see this is rotated in, this is not. These need to be swapped. You can see this green, white, and orange need to come here. This blue, orange, and white need to come here. These need to be swapped. And the only way that that's going to happen is if these need to be swapped. Now you can tell that these need to be swapped. If you were to try to solve this, you'd say there's no problem with this at all. These just need to be swapped. Here, you think this is correct, but they're actually not. They need to be swapped, and that's the key with this puzzle here. So these need to be swapped, but you can also see that not only do they need to be swapped, they need to be flipped. So too, this not only needs to be swapped, but they also need to be flipped, and that's what's happening with this puzzle, is these two need to be swapped and flipped in order to get out of this. So this isn't really a corner parity any more than this is. This is really an edge situation where these need to be flipped and swapped. So we'll take it step by step using this. So the first thing that I would do is let's get the edges in. So this is the L formation. So I'm going to hold it over here, and we'll go ahead and do the algorithm to flip these guys, or to get them all flipped right. And in the L configuration, do F U R U I R I F I, and you can visualize that this has been rotated correctly. Well, we're going to do the same thing over here. These are rotated correctly, these aren't. So if I hold it here, this is going to be the it's a little catchy, but this is going to be our L formation. So we're going to do the same algorithm. F. So again, if you're trying to solve in this configuration, bring it over here, where this is in the front and to the right, this is to the left and to the back, and it's F U R U I R I F I. Now, looking at this, it might look a little bit scrambled, but indeed what you did is you flipped these two are flipped. You can tell that they're flipped okay because they're both pointing in the same direction. If they're pointing in opposite directions, then they wouldn't be flipped right. But this is the configuration that it looks like when they're pointed in the right direction. So now we have something a little like this. The next thing that I would do is we could try to get our edges in place. You can see this is lined up here, this is lined up here, and these two aren't. So too, this is lined up here, and this is lined up here, and these two aren't. Okay, so the way that we would get everything back in is with this in and this in, you then move it to where the ones that are in are to the right and to the back, and do the SUNY algorithm RU, RIU, R2U, RI, and then one turn over means all these are in. So we're going to do something similar here with this one. We take the ones that are in here and here, I'm going to move it from here to the right and to the back and do R. Now you're going to notice something interesting. We're going to do RU, RIU, R2U, RI. Now what you're going to notice is these are all okay relative to each other. So if I were to actually move this in place here, you see this is fine, this is in the orange, this is fine here too, these are all fine, and these are all fine, but it caused the rotation here of the center, which also happened here, but you just didn't see. But don't worry about that right now. Now we're just going to go ahead and get the corners in and see if that parity is still there after we did all of our fancy maneuvering. Well, to get that back in, we take a look and see which corner is in. There's one that's in over here, and you can see the apparent parity is taken out because we just have one corner in. But let's see if it holds. So we're gonna go ahead and do the corner permuting algorithm. U R U I L I U R I U I L. You can see that still just one is in. Do it again. And you can see that now all of the corners are where they're supposed to be, and all we have to do is RIDIRD this into submission until it's all where it needs to be. This is the easy and fun step. And it's done. Okay, so too, let's take a look at this. Is there one that's in like we had the last time? One corner that's in. Well, we look at this corner appears to be in. This is white, orange, and blue. This is not in, this is not in, and this is not in. So that apparent corner parity seems to have been taken out. So we'll hold it over here, do that same algorithm. U R U I L I U R I U I L. And then one more should do it. Turn, 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 and turn. And now as you can see, our corners are where they need to be, so the corner parity is taken out. All we have to do is RIDRD this back into submission, so we'll go ahead and do that. RIDIRD, RIDIRD, D. So that's in. And now the next one, move this into place. This one's a little more snaggy, so I can't move this as fast as the other puzzle. This is in. Now we just do this, the next one here. All right, D, and again. All right, D. Now you can see all these are in, except we're still messed up, and that just means that this corner here, although it appears to be right, it still has to be rotated. Notice we had to rotate all four corners, so too we have to with this as well. So RI, DI, RD, and we keep doing this until the puzzle is fine on the other two layers. D, you can see we're not there yet, so we do it again. D, RI, DI, RD. And as you can see, we're very close to being done. But the whole key with that is it fixed the alleged corner parity issue that had happened. It wasn't really a corner parity. But what about this? What about this center? This center is rotated. It's off. By how much? Well, it's actually off by 90 degrees. See, this is where it's supposed to be. It's off by 90 degrees. So because of this, what I would say, now that I have a way of rotating this 180 degrees, but there's no way of rotating this 90 degrees. The only way to rotate this 90 degrees is if I rotated another by 90 degrees. To rotate this 180 degrees, if we had to do that, you simply do RU, RIU 5 times. RU, RIU, that's once. RU, RIU, that's twice. RU, RIU, that's 3 times. RU, RIU, that's 4 times. RU, RIU, that's 5 times, and it won't fix it. So basically the configuration, and I got it back in exactly that same configuration, and it's easy enough to deal with the apparent corner parity, but what you're not going to be able to fix is this. So what happened? Well, I think what happened in that case is, whether you realized it or not, or remembered it or not, at some point in your solve, something like this happened. It popped out. And you quickly looked at it and said, oh, let's pop it back in, and you popped it back in a way that you thought was correct, but in actuality was 90 degrees off. So if that happens, you simply turn, I would just put it back in. If that happens, just realize, okay, you did actually solve it, just that had occurred. So I think what had happened is that at some point, every time you get into this configuration with the centers, every time you get into that configuration, if that ever happens, just accept the fact that at some point it popped out and you popped it in wrong, and you just have to turn it back in, because that is an impossible parity. If you see this rotated wrong by the end of it and it's rotated by 90 degrees, it just popped out, so no worries. But if it didn't happen that way, it should be fixed, and that's how to get out of apparent corner parity. What happened is that these two had to be flipped, they had to be swapped, and they had to be flipped. So that's what had to happen. Flip them and swap them, and you should get them back. So hopefully that helps. Thanks for watching. Hello, me again. So here's another viewer question regarding the master ghost cube. Now, bear in mind, my color scheme is different than what he had, but I think the point is still the same. This comes from Michael Nagumba. Hope I'm pronouncing that right. He says, so I'm on the last layer. This is a master ghost cube, by the way. He says, so I'm on the last layer, and I see that there are 2 corners that need to be swapped. Now, I've placed the corners in the correct relative position. My question is, there's no way I could have equivocated on the centers on the opposite end. This guy over here. As you can see from the pictures of the top and the bottom of my cube, how can I continue from here to switch the centers, to switch the center 90 degrees clockwise? So what does he mean by 90 degrees clockwise? Well, he's actually correct. So looking at his particular puzzle, I guess here's a, again, my color scheme is different. So we're going to put this over here. But here's one angle that you can see. You see this sticking out over here. You can see this over here. So I put it in exactly the same configuration. And by the way, if you think solving a ghost cube is tough, try to do a different kind of configuration. And further pictures, he was just showing the bottom over here. That represents this side like this over here. So you can see, he was just showing that there's no false equivocation. Everything is exactly in where it's supposed to be, which I agree with. And then shows, and again, I know this isn't mass produced, but someday, hopefully it will. Then he showed this over here. You know, something like this. And as you can see, what he's got, although his is black, we've got this corner here, this over here. This doesn't have a small sticker here, but his does. Then you've got this triangle facing out over here, and then you've got this over here. So this is pretty much the exact confirmation that he had. And he's right. If you try to flip, what actually happens is that these are in the proper configuration. These aren't. But if you try to make it like that, these two have to be flipped. If you try to flip these two and then put these back in where they're supposed to be, this center becomes off by 90 degrees. As we look closer here to correlate with the other picture, just take my word for it, as he tried, and he did an apparent heroic effort with that, to try to flip these, everything would be in except this would be 90-degree rotation, and the only way that you're going to get out of that is if there's false equivocation. So again, this can't be because of an actual corner parity. There's no such thing. So is there an edge parity? Well, there's no equivocating edges, so there must be centers. Well, I'm going to trace this back to a while ago. I'd first made a tutorial on this puzzle over here before this was mass produced, when I bought my first one from Trepum, and I discovered this interesting and strange corner swapping problem here, which I thought was a parity, and I really hadn't worked out things such as false equivocation, but I couldn't understand how that would happen. But you can see everything is solved except these two need to apparently swap. Well, they can't do that because when you swap these two, you're going to end up swapping edges. If you try to swap the edges, the center will end up rotated, so that's not really going to work. So this led to the notion that to swap these, a single component of the center had to swap with another single component of another center. And that's really what's going on here. That this is an equivocation of these center pieces over here. So what I did to get out of it is I just swapped these two and just sort of see where things fell. So the way that would work is I found the equivalent centers. And what I did is I just took this and let's put this in this position over here. So bang, it's in here. I'm going to do a sliding U technique, slid it in from the right, slide it to the left, move it down on the left. Slide it back to the right, slide it back from the right over here, bring it to the left, slide it back on the left, and then bring this down. That won't change this at all, but you can see the configuration of the center has actually changed. And that makes all the difference. What I'm then going to do is, seeing that these are in the right place, these two need to be swapped. I'm going to swap them corner style. So all I'm going to do with that is do, well, actually, here's what I should do. Before I do that, since I'm correlating things from one puzzle to the next, I have to find something else that this can equivocate with. So let me put this in a position where it can be moved. Be sure, there we go. Okay, so in this case, Michael is actually correct. It's not equivocated with any of these over here. You can't do an exchange. I'm thinking maybe this, exchange with this, but it actually doesn't work. Now you can see, you can sort of see this doesn't quite fit over here, and I would say in your puzzle, it probably looks like it fits a little bit, but not completely. So look for something on the bottom over here. Look for something here. Do you notice anything that doesn't seem to quite fit? Well, as I look closely here, this doesn't quite fit over here. So there is something that can be equivocated, and that's what I would look for. So what I'm going to do is I'm actually going to take this piece and see if I can swap it out with this piece over here. So I'm going to move it into swapping position, and I'm going to do the same sliding U technique. Move it in from the right, left rather, and you can see it kind of fits here. Slide it to the right, move it down on the right. Slide it back to the left. Move it up on the left. Slide it back to the right. Move it up on the right. And I'm just going to move this back here. So everything here is fine. You can see this fits nicely. And now this is over here. Okay, what I'm going to do next, the next step is these two have to be swapped. And I'm just going to cleanly do that the same way that I would do it here, the same way that I would do any corner swap with any cuboid. Just moving from the middle, it's going to be 2R U, 2R, UI, 2R, UI, and then the bottom is a D, 2R, UI, 2R, U, 2R. This moves back, no problems, and now you can see that this is in. Now that I've done that, that should have recalibrated the puzzle so that now I can try to get it in exactly the same way. So I have this in and this in. These two need to be flip-flopped. Let's look at the corners. You can see this corner is in, these are not, so we have eliminated that parity. We'll just put the corners in U, R, UI, LI, U, RI, UI, L. Not yet. And turn. Okay, so now all the corners are in. They're actually where they need to be. What about this? Well, I'm going to do the URF algorithm. That's going to be 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. Okay, so what you're going to see is these are all in, but we have a 180-degree rotation of centers here. No worries, we know how to do that, doing what I said in the previous tutorial, R, U, RI, U, R, U, RI, U, and do it 5 times, or in other words, just keep doing it until it's back nice and safe where it needs to be. You see it's still over here, so we'll just do the same thing on this side. R, U, R, U, R, U, R, U, R, U, R, U, U, R, U. By the way, that eliminated that really long URF algorithm that I used to do. I don't do it anymore. So we're going to do the same thing here. Translate it to this ghost cube. We're going to go ahead and swap these two here. 2R, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R. That moves back, but we can just keep it the way it is. Okay, so you can see that this is now back in. The challenging thing of a ghost is you not only have the challenge of a 4x4 mod, you also have this whole ghost type concept. So now we should see that everything that we did, the apparent corner rotational parity, should be taken care of. So let's go ahead and solve this the way that we would normally solve this. So these two need to swap if we were to do that. Or better yet, we could just kind of get all the corners in. And it appears that the corners are in. This is in where it needs to be. This is in where it needs to be. Are these fine? Well, let's RID this until it's rotated and see if it is. So now with 4x4s, I do like to get the corners in first, believe it or not. And then I worry about the edges later. So RIDI, RD, RIDI, RD, RIDI, RD, DI, RD. So you can already see it's taken care of. I know this is in. I'm just going to finish RIDI, RDing it. Okay, so now this is right, and really that's the answer to the question as to how to get these in. Basically, there is false equivocation. It's somewhere on your puzzle. That's the only way that this can happen. Now, in terms of getting these back, well, what I can do is my algorithm to my URF algorithm to turn this, not the huge, horrible, long one that I used to use, just the simple one, to U, to R, to F, to U, to U, to F, to R, to U. Okay, so you'll find that swap these. This is at 180 degree rotated, so is this. Easily dealt with. R, U, RI, U, R, U, RI, U, R, U, RI, U, R, U, RI, U, R, U, R, I, U. So this is good. We just have to rotate this. Same thing. Don't let the ghostly features scare you. R, U, R, I, U. That's 1. R, U, R, I, U. That's 2. R, U, R, I, U. That's 3. R, U, R, I, U. That's 4. R, U, R, I, U. That's 5. That's been rotated. And now we turn it back into our solved ghostly cube position. And it's done. So a couple of reasons why I wanted to go through those. First off, they both have the same theme of apparent corner parity. If you see apparent corner parity, it's not the corners, it's somewhere within the edges or within the centers. Someday there's probably going to be a mass-produced master ghost cube. I hope that's going to come, so this may become important later on, but I figure this would also be important for those who have similar types of problems with similar types of 4x4s, such as this one, where there's apparent corner parity when it really is false equivocation. So just recognize that with your master ghost cube, if you end up seeing a situation where you can only have 90-degree rotation of a center, if it's on a 3x3, it popped out and you just got to pop it back in. If it's on a 4x4, it probably didn't pop out because they don't really centers don't really pop out in 4x4s, but it has to be false equivocation. So on a 3x3, center rotation, it got popped out. On a 4x4, 90-degree center rotation, there is false equivocation, either an obvious false equivocation, as in this, or a not so obvious false equivocation in this as well. So keep those questions coming. Pictures are always helpful, as it's a fun little challenge for me to get it in that configuration, and hopefully this will help for future solves. Thanks for watching.